Should be that loose paper by Cassidy's right arm. Not the one on top, the next one down. All right, so we just together graphed the photographer. So now we're going to graph this. All right? Now, why are the number of DVDs purchased on the left of the table?
Because they are into.
They are the independent variable. Why?
Because
Let Karina.
because it's the
one that changes the other one.
Yes. I wouldn't have described it that way. That's very Dr. Seussy way of spelling it or explaining it. But yes, if I don't buy a DVD, do I send these people any money?
no.
No. So the cost depends upon how many DVDs I buy. Alright? So this is the DV. So step 1 says graph the data. Well, on your test, I won't even give you this much. I won't even give you these dark lines. You'll have to do it all. But I've given you the axes here. What goes down here? The number of DVDs or the cost?
The number of DVD.
Why?
Because they are the
It's the x-axis, and that's where the independent variable goes. So this is the number of DVDs. Right? How many must I put on this graph? How many pieces of data do I have that I can actually put on the graph? 4. So I'm going to go ahead and I'm going to say 1. Do I have to write more than that? No, because that tells me that you know that 1 square equals 1 DVD. Cool in the gang? All right. What goes up the side? Cost. What should I do that in lumps of? What's it go up by? 5s, right? So I should probably go up by 5s. Do I need to write more than 1 5? No, because that tells me that 1 square is worth 5. Everybody cool? All right. Now, what is your first piece of data? 1 DVD costs how much? 20. So this is a data point, yes? But this is not an XY coordinate, is it? As an XY coordinate, what is that? What is our first point? 120, right? Now, who's in charge of where 120 lives on any given graph? You are. You told me that the x's are 1 square. So I go out to 1. Then I have to go where to get my y? Up to 20. Now we said each of these was worth 5 points, yeah? So I only got to go up 4 spots. 1, 2, 3, 4. Does everyone see how that works? I chose to make each of these 5, therefore that is 120. Even though when you count it, it's really only 1, 4, isn't it? But because we changed the scale, this guy is 120. Cool? What's your next piece of data? 225. Next piece? 330 and 435. Correct? Is it graphed? Excellent. So, we have done the first one. We have graphed it. Next, should the points be joined? Yes or no?
yes.
I have 1 yes, I have 2 no's, and I have 22.
Okay.
I said
I don't
no.
know.
I finally.
I say
You know
yes.
what's going on.
Yes.
Which is it?
Yes.
No.
I got the definition right here. Connect only if fraction inputs are allowed. Omar, can I go to the store and buy half a DVD? No. So, can I have, at this point, which is half a DVD, can there be any amount of cost for half a DVD? No. So do I connect the line? No. No. Can't buy half a DVD. Doesn't work that way. Walmart will not let you come in, buy The Force Awakens, watch an hour of it, take it back and say, you know what, I didn't like this. Doesn't work that way. But I did watch an hour of it, so I'm going to pay you $10 instead of the $20 that it was going to cost me. Doesn't work that way.
But the ending
Is the relation linear? Read the definition. Do our outputs make a straight line? Yes, because I go up 5 over 1. 5, 1. Up 5 over 1. Up 5 over 1. What's the next one going to be?
up 5, 1.
So it's going to be
5,
40. So is it linear? Yes. Why?
Because it's,
The up and right are the same. Describe the patterns. So now I need words. Can I say X and Y? No, because that doesn't describe the pattern in the graph. What must I say here?
the number of DVDs and use the cost as well.
Exactly. So what would you say here, James?
The number of DVDs when they have one more, you add 5 to the cost,
Okay.
and the starting cost is at 20.
There you go. The first DVD is $20. What if I want to buy more?
The discount is 15.
Yeah. Each subsequent, or each, yes, I like using fancy words. Each subsequent DVD is how much? $5. Easy peasy lemon squeezy. Right? Here's where you're going to make mistakes. 1, you're going to join the points at the wrong time. You're going to. Unless you listen and think. Then, you're going to not join the points, which is often correct, but then you're going to tell me it's not linear because you never actually drew a line. So you say, oh, I can't be linear.
But you can still draw a line.
That's not what makes it linear. What makes it linear is the fact that it changes in a constant fashion. Does everyone understand?
Yes.
I know it's weird to say something can constantly change, right? Constant means it doesn't change, and change means it does. So how can something constantly change? It's just another weird thing in English.
Whoa.
You okay there, James? Is your house burning up while it burns down?
Ah!
Are you backing up while you back down? It's another one.
So much logic confused.
If you stand up and I start running at you and I'm going to punch you in the face, you're going to back away from it. That's backing up. But you're also backing down from my challenge. They mean the same thing. They use two different words that are opposite of each other, up and down. I would never run at a student and punch them in the face. That was for illustrative purposes. All right, let's see if you guys can actually figure this out. I have been very nice and helped you with this graph. I put the number of floors down here and the building height here. Why?
You like us.
Of course I like you. But why were the number of floors here?
Because the number of floors is the independent variable. the other one's dependent variable.
Why is the number of floors the independent variable?
Because it's the one that changes the other one.
Yes. As you go up each floor, you are going up in height. Is it possible to be higher up off the ground but not be in this building?
Yes.
Yes, you could climb a tree, couldn't you?
You could be on that hill.
You could be on a ladder. You could be on a hill. You could be hang gliding. You could be using this thing.
Oh, my gosh. The water is oh, is that?
No! Water is for wusses.
Do you want to try this? I can tell you right.
Water is for wusses.
Oh, I did that.
No, you did it with water. I'm just kidding, Zach. I'm just kidding. Wait. Of course we have...
Yes, I saw that. It's so good. You gotta edit the boat.
It's too slow, you know.
You have to be low so you can get that enough to do.
What?
You gotta edit this out.
No, I don't.
We didn't even take yeah, I know.
YouTube's got bigger fish to fry than me with my math stuff. They're too worried about the 7 million people that are wasting their time watching Lily sing.
You don't like Lily sing? Who's that?
Anyway, maybe it'll load up later and I'll show you. Anyways, you can be off the ground without being in the building. Alright, so, now that we're set, what are the points that I need to put on my graph? You guys go ahead and graph that while I answer this phone in a pleasant fashion.
Go for mine.
Go for Myers. No, he did not. Okay. Bye.
Wow, they're probably like.
Did you graph this yet? You need to put 4 dots on here. Where are they? What's the first dot? 1, 5. What's the second dot?
2, 8,
Third dot.
3, 11,
Fourth dot.
4, 14.
Put them on there. 1, 5. Oh, but 5 isn't on there, so what do I have to do? Put it in the middle.
In the middle.
2, 8. 3, 11. Oh, it's not on there. Put it in the middle. 4, 14. Yeah? Yeah. Is the relationship linear?
Possibly because
Yes. Why?
because we have half the floor.
No.
That's the wrong one actually.
You're answering the wrong one. B. Is it linear? Yes. Because each increase, forgot the A in increase, nice spelling, Myers. Each increase in floor gets a 3-meter increase in height. So, how tall is the building going to be at 5 meters? At 5 floors?
It's gonna be
17 meters. 6 floors. 20 meters. 7 floors. 23 meters. 8 floors. 26 meters. Everybody got it? Now, we're going to do some more work with that, writing the equation from the chart, because you're probably still a little bit weak at that, and you probably forget how to do it because it was 4 days ago. We're going to talk about that in a minute. But first, we're going to deal with this. James,
yes.
do I join the points on the graph?
Yes, because you can have half the floor if you're on the stairs. Because logic.
Absolutely right. This time, we do join the points. Why?
Because you're going back and forth.
Because you could be between floors.
On stairs.
And you would still have a height, right?
Yes.
If I was Spider-Man,
What do you mean? What do you mean?
I don't remember this.
no, Spider-Man is the best hero of them all. There is no one better than Spider-Man.
Have you watched the Amazing Spider-Man? Like,
No one better than Spider-Man.
Iron Man's better.
No, Spider-Man in general. I'm not talking about the films. The films all suck. Spider-Man himself
his powers.
is the best superhero out of all of them.
Well,
What?
It has no
Nice.
how about
So, if I am Spider-Man, who looks a little bit like
Deadpool?
Deadpool, can I be between floors?
Yes.
Yes. Am I still off the ground?
Yes.
Yes. So I connect the line.
So you can jump and just be like,
Okay?
yes.
Okay.
Okay. Now, next thing I want to do is remind you of how to do this. How do you tell me what the height is going to be when I'm F floors off the ground, which is unknown? Okay? So remember, this is how you do it. Remember, every equation is your dV equals your IV with math, yes?
Yes.
Okay? So, here is a dV value, yes?
Yes.
It's 5. So it must equal my IV, which is 1, and then some math, yes?
Yes.
What is the math that is happening here? I am adding 3. Do math guys write plus 3, plus 3, plus 3, plus 3, plus 3? What do they write? Times 3. So it must be 3 times 1, correct?
Yeah.
That had to happen. Now, I need to get the 5. What is 3 times 1? 3. What do I need to do to get the 5? Add 2. Okay?
Yeah.
Check the next one. So now, 3 times 2 plus 2. Does that get me 8? Yep. So I know I'm right. So what is it? 3 times what?
3.
F, because floors are F, plus 2. And now I will know the height of every single floor. Do you understand?
Yep.
Everybody cool?
Yes.
All right. So that is a real life situation, yes? Everybody cool with it?
Yes.
All right. So now we need to transfer that knowledge of a real life situation. I'm climbing up the wall of the building, I'm off the ground, to a mathematical idea. Because the mathematical idea can be applied to every other circumstance. Do you understand? That is why we study math the way we study it. What am I ever going to use this in real life? You're not. Because in real life, you are never climbing up a piece of paper and walking crossways. That's not real life. But this, which is up a piece of paper and across a piece of paper, is a representative of real life. Understand?
Yes.
That's why we study math the way we study it, because we can apply it later to the real world. The principles still work.
That's what I found.
Right? If I have 3 apples and you have 10 apples and we have 5 people to feed, is that a real life situation?
Yes.
How do you figure out how many apples to give them?
You give them each one.
By doing what? Math. You do 3 plus 10 divided by 5. Is that a real life situation? No. Because 3 plus 10 doesn't mean a thing. This is a 3. That is a 10. That is a 5. That's not real life. Right? But 3 apples plus 10 apples shared between 5 people is real life. If you can't do this math, are you going to be able to do that real life problem? No. Well, you could. I mean, you could sit down. I got a pile of 13 apples. 1, 2, 3. You could do that like in cartoons, and you'd have some apples left over. But when there's 13 apples, easy to do. When it's billions of dollars, you got to know the math, right?
Yeah.
You can't sit down with a pile of loonies and start doling it out to people.
Like, what?
All right. So, we are now changing this to mathematical principles, which work all the time. Now, the first thing I got to do is I got to look at this thing right now and say, is this a real life situation?
No.
No, because we don't know what X and Y are, right?
Yep.
So right away, we're just thinking math.
Yep.
All right. This says what? What does this point on this table mean? That X is negative 2. In this question, is there an X somewhere?
Yes.
Where? Right there. What is that X? According to this, negative 2. So what do I write here? 5 minus negative 2, which is what?
Equals 10.
7. So now, X is negative 2. When X is negative 2, what is Y? Positive 7. So what's the point that we put on our graph?
You put the point 7 and negative 2.
Negative 2 and 7. Okay? What's this tell me X is?
Negative 1.
So I do 5 minus 1, which is what?
6.
6. What's the point that would go on the graph?
Negative 1.
6. 5 minus 0.
5.
5. What's the point for the graph? 0, 5. Now, do you need to go any further, or do you see the pattern?
I see the pattern.
What's happening to my Y's?
They subtract the
They're going down by 1. So 7, 6, 5, 4, 3. Correct? All right. So we filled in our table. Now we can come down here. We can go negative 2, negative 1, 0, 1, 2. 7, 6, 5, 4, 3. Now graph it. Negative 2, 7. Negative 1, 6. 0, 5. 1, 4. 2, 3. Now, what is happening? We've graphed it. What's the pattern?
It's
As X increases by 1,
Y decreases by 1. So soon
Y decreases by 1. Does that continue to happen?
Yes.
So is it linear?
Yes.
This is linear because it's the same pattern. Now the question becomes, can we join the points?
Yes,
Because it's written right on the page.
yes.
Since we can substitute any value for X, we can join them. What does that mean in math though? Can I put any value for X and subtract that from 5?
Yeah.
Could I put 1.17923?
Yes.
Yeah, and the answer would be 5 minus 1.7923. And that would give me a value, wouldn't it? So I can connect the dots.
Yay.
Is everybody cool?
Birds.
Yeah?
Yes.
If you're lying, you're dying. Nobody's lying? All right, prove it. Graph number 1.
Oh, yeah.
I'm going to sit here and hum the Jeopardy theme 3 times. That's how long it should take for you to graph that. Go. That was once.
Okay.
That was twice. Bum, bum. That was 3 Jeopardy themes. You should have been able to do it. What number goes here? 2. Why? Because 4 times 1 is 4, minus 2 is 2. What number goes here? 6. Because 4 times 2 is 8, minus 2 is 6. What are the points that go on the graph then? -1, -6. What is this one? 0, -2. 1, 2, and 2, 6. Now we come over and graph it. -1, -6. Bottom. 0, -2. Bottom. 1, 2. Bottom. 2, 6. Bottom. Now, have you done it right?
Yes.
Do I stop now? Is this graph complete?
No, because you gotta know if it's linear, go left.
No, it is linear. I can see that it's linear. Up 2 over 2, up 2 over 2. So I know that it's linear.
But you haven't drawn the line through it.
Why do I connect the dots?
Because it's possible that you can have a half line.
Can I put a half in there?
Yes.
What's 4 times a half? 2? What's 2 minus 2? So there would be a point at 1/2 0, wouldn't there?
Yeah.
Is there a point at 1/2 0?
Yeah.
Over 2, up 2. So over 1, up 1. Oh my gosh, there is. So do I connect the line?
Yeah.
Abso-smurfly. How far will that line go?
Infinite.
Forever and ever and ever, just like the weird chick on iCarly. I'm so happy iCarly's back on Netflix. I've been going through iCarly withdrawal. Very happy. Although iCarly, Miranda Cosgrove, is on a new show. It's called Crowded. It's pretty funny. And weirdly, her name is Shay on the new show. I think they did it on purpose because I don't think Miranda Cosgrove might not be smart enough to understand that she might have another name as an actress. I'm just kidding. Miranda Cosgrove could be brilliant. I don't know.
What?
Miranda Cosgrove, Carly, is on a new show. Her character's name on her new show is Shay. Carly's name was Carly Shay on iCarly. That was her last name. Okay. Yeah, I know. I'm a bit more of an iCarly fan than the average 40-year-old male. It is because my daughter originally started watching it, and I thought it was stupid. I would never watch. I was like, that's a dumb kid's show. Stop it. Turn it off. You're smarter than that. Then I started watching the show, and I was like, holy crap, this is funny. And now I realize how good it really was, because now my daughter's been watching Some Assembly Required on the same set as iCarly. That is the only thing that is the same as iCarly. It's the same sets, because the show sucks. They're so stupid. The show Some Assembly Required.
It's on the same set?
Yes, it's the same set. Watch it. It's in their apartment.
But it has a roller coaster.
Oh my gosh, that's not a real roller coaster, you guys. It's a green screen.
No, it's a real roller coaster.
Oh my lord.
Isso é mais que eu vou
Okay, you guys try the next one all by yourselves. I'm going to be up here minding my own business.
Okay.
Do you already have the points graphed for yourself?
Yeah.
Or not graphed, I mean. You have the points in a table, right? What are they?
It's the 4.
1, 40. 250, 360, 470. So graph them. Are we happy with our graph? Is everyone happy with their graph?
Yeah.
Okay, now look at the next question. I'm not going to tell you the right answer. And look at how differently it's worded. Does it make sense to join the points on the graph? Yes or no? And then I want a reason. I'm going to wait a moment while you think of your reasons, because I'm not going to tell you if it is right or wrong. I'm going to let you be the lawyers that you all wish to be and let you argue your point. Because I'm going to tell you right now, there is no right answer. The marks for this question would come from your reason.
No.
Yeah, stand up to the other side.
Is there anyone in the class that would wish to explain yes or no and their reason? I know that James would. Go, James.
Yes.
My reason is because you can have a half an hour bowl, like a quarter bowl, a 7-minute bowl. You can have any amount of bowling.
So
Like,
James says he can bowl any amount of time, and he feels that the bowling alley will give him a deal based on the amount of time he is there.
yes.
Okay. Would anybody like to refute that statement? Connor.
It would also come with that. It would not make sense because there's no half.
Connor says it won't make sense because there's no half.
If you look at check number 1, you notice that it goes up by 2, then 2 again. But this graph only goes 1, then 2.
So Connor says, James, Connor says that because they're only charging for each hour bowled, Connor says that if you go over 1 hour, what are they going to charge you? For 2 hours. Right? Is either one, based on the information we have, correct? Or can both be considered correct? Because if you connect the line, is James right? Could you say then, okay, well, I only bowled for 2.5 hours, go up, so I should only pay this much because that's where the line hits. Is that okay? Sure. But is it also okay to go with Connor's saying, you're paying by the hour? So what happens if your game goes over 5 minutes? What should you do?
Bowl for a whole.
Bowl for another 55 minutes because you're paying for it anyway.
It's like, I'm only going to bowl.
Everyone understand? It's how cell phones used to work. Back in the day, you paid by the minute for a cell phone call. There was no unlimited calling to anyone. You paid for every minute. So people would have conversations like this. Hey, how's it going? Yeah, I'm on my way there. I'll meet you at the Tim Hortons at 5:30, and then we'll go over to the movie theater right afterwards, and that'll be okay, right? Okay, good, click. Okay? Now, what happened then was you would be talking. What? That's not okay? Wait a minute. Well, what do you want to do? I don't know what we should do. 101. Right? Flipped over to 101. Okay, let's talk about this. Because now you had a whole minute that you were paying for anyway. And then the smart cell phone company said, no, we're going to charge you to the second.
No.
And then you could connect the line. No, it was a line like this, like 20 cents a minute, right? But then they would break it down. A 60th of 20 cents was a second. Understand the difference? So you could just talk. You didn't have to narrow it down to a minute. Okay, yeah, like a house phone now. If anybody still has a landline, I doubt many of you do. We do. I do. I don't need it now that both my kids have phones, but
Who doesn't like to have a
my daughter is 9, but my daughter does more than most of you people do, so she needs a phone. She's at swimming lessons, karate, she walks home by herself, she's in musical theater, she's all over the place, so she needs to have a phone. She needs to have a phone to communicate with us. That's the only reason she needs a phone.
Some weeks are boring.
I know, that's what it should be. Alright, so this answer was depends, doesn't it?
Yeah. Because there are 2 answers.
How is the bowling alley actually charging you?
There are 2 different ways to do it. Yeah.
Are they charging you per hour, or are they charging you for the amount of time you bowl? Do you understand the difference?
Yeah.
Per hour, we can't join the line. But the amount of time you bowl, we would join the line. Does everybody get it?
Yep.
Now, is there a right answer to B? Yeah. What is it?
Yes.
Yes. Why? Because I go up
1 and then
10 and over 1. Always. Every hour costs $10. Always. At this bowling alley. Now, what's the pattern? So now I want the equation. When H increases by what? 1. C increases by 10. Great. That's it in words. But now I want the equation. So how do I do that? I go up to here and I remember dV is always IV and math. Right? So my dV is cost equals my IV is H, and then some math is happening to H. What? Adds 10. Now we don't write plus 10 plus 10 plus 10 plus 10. We do 10H. But H is 1. What's 10 times 1? 10. But I don't need 10. I need 40s.
so 40 plus 40.
Plus 40?
Now you're plus 2.
Plus 30. 10H plus 30. And then we check. Does it work for everything? Is 10 times 4 40?
Yeah.
Is 40 plus 30 70?
Yeah.
So we know we're right. Everybody Gouda? Great! You are going to work on page 170. I will, Omar, like I always do.
Down.
Page 170 in your outline that's on the front. And I'm giving you, holy crap, 35 minutes to get it done. Yep. Omar,
You go all the way here.
Is this a coming time to leave or just like to go back?
how many times you leave?
Can I do please?
If you wish. Omar.
Oh,
Or was it this page with the DVDs?
yeah.
35 minutes. Go. Maybe it's loaded up by now. Yep.
And then eat it. I don't think so.